Yes.
I've got a little starter, so I'll just explain it because it looks a bit complicated. On my far right-hand side, the column has the name of the angle in blue, the description in black, and an example of what the angle could be in pink.
Yes.
Yeah, and what you can do is you can drag and drop all of these. If I thought this one was this one, I'd drag it and drop it.
Yeah, okay.
Okay, and they're all there. And then once you get down to the bottom, there's new shapes. And then for those, just name the shapes and what angle the shapes add up to, kind of thing.
Okay.
Okay, I'll help you along as you go.
So this one is an acute angle.
Yeah.
Let's put it there.
Brilliant. I couldn't remember if I'd said those names last week, so I thought I'd add them in today.
It is less than 90.
Yeah.
Yeah, I should put this here. Yeah, there we go. Yeah, example, let me see. It has to be less than 90. What does it mean by example? Like it says 180 degrees, but I can't see anything less than.
I hope that I put one in. Oh yeah, I don't think I did. Okay, what could an example of this be then? What kind of angle was less than 90?
80?
Yeah, it could be 80, so I'll put 80 degrees. I think I forgot that one. It was supposed to be 26.
Yeah.
I mustn't type it in. What was I going to say? I can't remember. Carry on.
This one is the right angle.
Yeah, brilliant. Right angle.
It's 180 degrees.
Are you sure?
No, I was talking about the example one. It's 90.
Yeah, it's 90. Can you find 90 in the list?
Yeah, over here. Yeah.
Brilliant.
And adds up to 180.
Not quite adds up to 180. The angle equals 90, so the example must just be 90.
Yeah.
Sorry, I know that's a bit confusing, but it was still getting to fit with the columns.
Yeah.
Yeah, brilliant. 90.
This one's obtuse.
Yeah, brilliant.
It is what is it? Angle is more than 90. This one 180. This one.
Yeah, angle. Is it more than 180?
Yes.
Are you sure? So if this is what 90 degrees looks like, hang on, let's get my finger pointer.
No, it's more than 90.
Yeah, it's just slightly more than 90 because if you remember, 180 degrees is a straight line. Do you remember that from
Yes.
right there? Yeah, so it's kind of that in between. It's more than 90 but less than 180.
Yes.
That should probably say that.
And it adds up to 180.
180, not quite.
No. But less than 180.
Can you see any other examples in there of degrees?
135 degrees.
Yeah, 135. Brilliant.
And this one's a quadrilateral. Oh no. Wait, let me see. Scroll down. No, this one's a reflex angle.
Yeah, brilliant. Really good.
Yeah, maybe there. And angles are more. Is it more than?
More than 180? Because if you see, it's way past the straight line.
Yes.
So it must be more than 180. Yeah, brilliant. Now there's a few options for the example, but there's one that specifically relates to the example.
It's 270 because.
Yeah, it could be something like 270. Yeah, brilliant.
Now, this down underneath. This is a square.
Yeah, it's a square. Does it have another name?
Quadrilateral.
I mean, the square, yeah, it is in the quadrilateral family, isn't it? Yeah, because it's got 4 sides.
Yeah, and quad 4. Let's see the next one. Description is, isn't it?
Now, what is the total of all of the angles in a quadrilateral? Can you remember?
8, 4. So each of them is 4. So 4, 8,
Yeah.
16. No, 4, 8, 12, 16.
So there's 4, and do you remember what each of these angles is equal to?
40.
Not 40. Does this match any of the pictures above?
Let me see. Oh, 90.
90, yeah. It's got 4 right angles, a square does.
Yeah. So, will it? Yeah, 90.
So what will the total number of angles in the square be?
360.
Yeah, brilliant. 360 degrees.
Adds up to 360.
Adds up to 360, yeah. So that's what the ones are for.
Yeah.
I'll bring the rest of them down because...
Yeah. Now the next one. This one is a triangle. Oh no.
Yeah.
What happened? Hold on.
I'll bring all the names down to the bottom for you.
Yes. So this is the triangle. It's only 3. It has a right angle over here.
Yeah, do you remember how we worked out what this one was on Friday? We said that normally we have a triangle, say like this, and if we can make a triangle by splitting this square in half, can't we?
Yes.
So if a square has 360 degrees in total, how many does a triangle have?
360. Half 360. And 180.
Yeah, they all add up to 180.
Yeah.
So I'll slide that in there for you.
Yeah. And this one's a. Yeah. This one's a circle with a full angle.
Yeah. All I mean by full angle is it's like as if we had 2 lines and the lines are together, so it's like the full angle. Does that make sense?
Yeah. It's going to be 180 because the line.
Are you sure? Well, that's true, but if you look, we've got the angle on the line down beneath it, don't we? This one's the angle on the line.
Yeah, so it's going to be 360.
Yeah, so it's double, isn't it? Because the angle on the line's like a semicircle.
Yes. And this one is
And the angle on the line is 180 degrees.
Yes.
How do you feel about that?
Yeah. This one, the circle and the semi one, I thought it was going to be a thing, but because it's turning, it's going to be 360.
Yeah, it's going to be 360. Okay, so I've got another little page of recap in case you wanted to do some more work on angles. So these are the options. We can go straight on to where we left off yesterday and go on to more like shape type things, or we can do another little recap and use some of the things that we've learned about angles to see if we can find some angles. I think there's a page on it later on in the book, but it's later on in the book and the angles are harder then. It's on page 52.
Okay.
So it's entirely up to you. I don't mind which one you want to do. We can do a few of these if you want it, and then do the shapes one, or we can do the shapes one and come back to angles when we get to page 52.
Let's do the page one.
Yeah.
Yeah. And then.
Okay. So I think on Friday we kind of did question 1 on page 51.
Yeah, we done the question one.
Yeah. So I'll just go through the answers again. We'll not measure them again.
So,
do you remember what they're called?
Yeah. The first one's a rhombus.
Rhombus, yeah.
Each side was 1.9, and the next one was a trapezium. Yeah. Only one side was the same, and the next one was parallelogram, and only the top side was the same, and both of that order was for the same, and for the parallelogram all of the sides were the same.
Yeah, so this is kind of the recap. It's quite hard to see, so I'll just put a little line. Oh, no, don't turn it blue. Never mind. Yeah, so rhombus, every side's the same length, and do you remember we denote that by putting these little lines?
Yes.
The sides are equal?
Yeah.
And on the trapezium, we've got 2 sides are equal. On the parallelogram, we've got the 2 long sides are equal, and then the 2 short sides are also equal, but not equal to the long sides.
Yes.
Yeah, brilliant. Okay. David has a new 3-sided chopping board. He has 2 sides of equal length, 2 angles of equal size.
And 1 line of symmetry and no rotational symmetry. What is the shape of the chopping board? Okay, so line of symmetry is when they both meet.
Line of symmetry is when you can fold the shape in half and none of it overlaps, it touches perfectly.
Yeah, so it could be a rhombus.
It could, but how many sides does a rhombus have?
Yeah, it has 4.
Has 4, yeah, it's a quadrilateral, but this one's only got 3, so what shape must this one be?
A no. Can't
Yeah, it must be a triangle.
But how?
What kind of different triangles were that?
Yeah, it has 3, but how can it fold up? How can it have a... Yes. It's a triangle, because if you fold it.
Yeah?
Yes.
What kind of triangle?
An equilateral. Not an equilateral.
Nearly. Really good guess, because it has 2 angles, 2 sides equal length and 2 angles, but an equilateral triangle has 3, because all the sides are the same length.
Yes. So, not an isosceles. What about, it's not going to be an isosceles.
Are you sure? Why not?
Yeah, yes, it is.
It is, yeah?
Yes.
Because it's got 2 sides of equal length and 2 angles of equal length. Yeah, brilliant. There's the little information graph thing that we had from last time. So because because the isosceles has two